here's our section 6.2 recap. So for this section, we talked about the t-distribution, which is related to when the population standard deviation is unknown, the sample size is less than 30, and the random variable x is approximately normally distributed. It follows a t-distribution, and we can find that t as x bar minus mu divided by s, which is our sample standard deviation since the population is unknown, divided by the square root of n, where n is the number of samples. Critical values of t are denoted by t of c. Back when we were talking about samples bigger than or equal to 30, we used z of c, which was our z-score. Now we're using this notation. And it's going to be just a little bit different table, and we're going to use a different thing in Excel. So the properties of a t-distribution. The t-distribution is bell-shaped and symmetric about the mean. It is a family of curves, each determined by a parameter called the degrees of freedom. The degrees of freedom can be found by subtracting 1 from n. So as n increases, degrees of freedom also increases by one variable less than n. The total area under the curve is 1, or 100%. The mean, median, and mode of a t-distribution are equal to 0. And as the degrees of freedom increase, the t-distribution approaches the normal distribution. So after 30 degrees of freedom, the t-distribution is very close to the standard normal z distribution, which makes sense because if we go back and look over here for just a second, if we look at the degrees of freedom, how can I increase the degrees of freedom? Well, to increase that, I have to increase n. And we also know as our sample sizes get bigger and bigger, closer and closer we kind of get to the normal distribution. So we're using t to get us close before the sample size gets big enough to use the normal distribution. So for instance, a degree of freedom of 2 would look something like this. 5, and then the standard normal. So the bigger the degrees of freedom, the closer and closer it gets to the standard normal. So for a confidence interval for population mean, we use this formula. X bar minus our error and x bar plus our error, where we can find error to be as this. Now in 6.1, we used z of c times sigma over the square root of n. For this case, we don't know sigma, and our population is less than 30, so we have to use our t value here, and then times it by the standard deviation of the sample divided by the square root of n. The probability that the confidence interval contains mu is c. Now, we randomly selected 16 coffee shops and measure the temperature of the coffee sold at each. Sample mean temperature is 620 degrees Fahrenheit with a sample standard deviation of 10. Find 95% confidence interval for the mean temperature. Assume the temperatures are approximately normally distributed. So we're going to use the t-distribution because n is less than 30, sigma is unknown, and it says it is approximately distributed. So we are fine using our t-distribution. So first, when we're using this, let's use the CI calculator to find the confidence interval. So first, find the critical value. So we know from the problem that n equals 16, x bar equals 162, s equals 10, and our confidence level is 0.95. Our degrees of freedom can be found by taking n and subtracting 1. And then we're going to find our critical value. So what we're going to do is we need to open up Excel and look at our calculator here. So to find the critical value, what we need to find is we need to go in here to function. We need to find t.inv.2t, and I can zoom in on that for just a little bit, I think. Oh, hold on. So I can't really zoom in very well, so I'm going to take this back out. Oh, are you serious? Okay. So now I need to get back over here, and I'm going to find this, and so I'm going to do t.inv.2t, and then for my probability, it's 0.95. 0.95. My degrees of freedom were 15. Now, one thing that's important is I forgot to put this 1 minus 1.95 here because we want the right tail. And so we get this 2.131. Now, if I go back to my PowerPoint, you notice that I've put this in here. The t.niv.2t is 1 minus our critical value. I mean, we're trying to find, Lord have mercy.